Now, not all polynomials work out the same way. In other problems, you're not going to get simple integer values for your factors. You might get rational numbers or non-real numbers. And for this, we've got a way of figuring them out a little easier. First, we take our problem. Let's go back to our previous problem and get all the numbers here, including the signs, and not skipping anything, just to make sure we've got everything we need for the formula. Okay, so now we have to find the possible number of roots, whether they're positive, negative, or non-real. So, with the positive ones, we go by Descartes' rule and count how many different times the signs change going down this polynomial. The number of times it changes is the number of possible positive numbers. So we go from positive to negative, that's 1. To negative, that's not a change, so we discard it. To positive, that's a second one. To negative, third. Back to positive, fourth. Stays at positive. And then to negative, fifth. That means there are possible 5 different combinations, 5 possible positive numbers. Which means that also the total amount of roots that you can have at all is 7. So we know total is 7. The negative roots are the number of roots you can plug in, are the number of roots you can count up after you switch all the x's to negative x. So, negative x to the 7th is still going to be negative x. Negative 2 times negative x to the 6th, this will become positive, but still stays negative because of the 2. So this is negative, positive, so that's one change. Then we put negative x here, and it would be negative, but since it's times another negative, it becomes positive. Negative x to the positive exponent makes it positive, and then this makes it positive, so this stays positive. Negative x cubed stays negative, but then becomes positive because of the sign here. 2 times a negative x squared, positive, stays. Then 5 and x. There's no exponent here, so negative x here stays negative, and then no x, so we don't have to do anything there. And now we count them up. Negative to positive, that's a change. Then positive to negative, that's a change. So 2, and stays at 2 because this is still negative. So there's a total possible of 2 negative numbers. That means non-real for this particular set can only be 0, because you've got 5 of the 7 roots positive and 2 of the roots negative. But there's more combinations to this. For example, there might be only 3 roots that are positive because of conjugate pairs, such as x minus 3, x times x plus 3. Those are conjugate pairs. They can cancel each other out, so there can be other numbers. So this can be 3 stays at 2. And there's only 5 here, so there's possible 2 non-reals then. And then if you subtract 2 more conjugate pairs, remember you gotta subtract them in pairs of 2. Otherwise, you can't do it. And you can only do it until you can't subtract any more 2's. So we've done that. And there can only be a possible amount of 2 negatives. So that means of the 7, 3 can be positive and negative, and that 4 are non-real. So let's keep in mind 5, 3, 1, 2, 2, 2, 0, 2, and 4, because there's more combinations. For example, there's 5, 3, and 1 here. For the negatives, there can be 2 or 0. So 5 and 0, that means there's 2 non-reals. 3 and 0, that means there's got to be at least 4 non-reals. And 1, that means there's got to be at least 6 non-reals. The question is, which of these combinations do we have? Well, we've already done a little bit of work on it. From the previous problem, we found that we have a negative root and a positive root. Remember, this is going to be x equals 1, and this is going to be x minus 2. So we already know that there is at least 1 positive and 1 negative. So that means all of these here can be discarded. So we just halved our list, and now all we have to know is how many more positives, negatives, and non-reals are there. Well, we already know that it's going to be 2. We already know that it's going to be 2 negatives here. So do we have 5, 3, or just 1 positive number? And then how many non-real numbers do we have? Such as the a plus bi problems. Your non-real numbers, like I. Well, that just basically means we've got more work to do. But if we want to find possibly a rational number, which is another way of finding if there's a positive or negative, there's a way to do it. It takes a while, but there's a way to do it. Let me just write these notes up here to make sure we remember later on. Because this is going to take a lot of space. Basically, it follows the rule that you take your highest number here, you take your highest quadratic number, and then you take the factors of these two here. So, we've got 1 minus 3, 0, 0, negative 1, and 3 left over from our last problem. And let's try, well, we've already tried negative 3, which didn't work. So let's try positive 3, which would be x minus 3 as a factor. So, 1, and then we take 3 times 1 is 3. That makes 0 after adding up, times 0, add 0, times 0, add 0, times 0 is 0. Then we got negative 1. 3 times negative 1 is negative 3. Hey, 3 worked. So that means x minus 3 is also a factor. But what else does this mean? Well, we went from 7 to 6 to get this, 6 to 5 to get this, so this one's 5 to 4. So x to the fourth, no x to the third, no x squared, no x, minus 1. That is what we've got so far for our problem. But hey, guess what we just did? We found another factor. In fact, we found another root, a positive root. So, that means there's at least 3 then. 3 or 5. So there is a possible of no, there's no way you can get 4 non-reals now. We're whittling away at this problem, and we'll finish it. The question is, what's our answer gonna take? If we're gonna try and get this down to all zeros, in other words, everything's gonna be factored out completely, we gotta pick a number that'll do this. What about 1? 1 times 1 is 1. Actually, negative 1. So that becomes negative 1 minus 1 is 1. Negative 1 times negative 1 is 1. And it worked. We actually got a value of 0. So that actually means that negative 1 is going to be a factor. X plus 1, x minus 1. There is a conjugate pair there. So this gives us x to the third minus x squared plus x. Sorry. Yeah, that's right. And then minus 1.